Okay, I think we are live.
Yes.
We are so back. And today I'm with the Isaque with me
Hello,
to talk
guys.
about system design.
Yes.
So the
Yes.
idea today is we're gonna read some articles about
Articles.
system designs, and we're gonna discuss and talk about the how important system design is for developers. Nice. So we have around 30 seconds delay on the YouTube, but we are good to go.
Fine.
So I'm gonna share my screen here.
StreamYard is so good. Very easy to use.
Yeah, very nice. Yeah, I still need a second monitor, how you said. Okay, so the first one, I didn't check if it in my audio. It's okay. Let me check. Oh,
Yes, it's good. I
it's
think
good.
in the call is good.
Ah, in the YouTube. Okay, nice. Okay, so the first one I'm gonna read it's how Discord stores trillions of messages. So system design, it's about a software engineer define how to build the system before starting coding. And Discord in 2023 had a problem with the messages and need to change the database. So we want to understand why and how they did that. And welcome from who you are there. We are mainly doing the live stream in English because we want to practice English. But if it's
Yes.
somebody don't understand, you can put em português. Pode botar a mensagem em português e a gente vai ler em português e responder em inglês para você praticar também. Right? Nice. So in 2017, we wrote a blog post on how we store billions of messages. So they wrote another post. Nice. I remember that one. I think he talked about Rust too, right? Or not?
In this article,
Yeah, let me see.
MongoDB.
No,
Rust.
just MongoDB and Cassandra. Yeah,
I don't know about Cassandra.
it's an awesome database. So that's the idea. The idea it's we understand more about some technologies that big techs use to scale their products. So for example, Cassandra from Apache. Apache, it's an open source NoSQL database. Maybe we should read that one first. What do you think?
Yes.
That one. Yeah, billions, right? Billions.
Billions. And after that, trillions.
Yeah. So let's start at that. So Discording continues to grow faster. By the way, 17 it's around how many years ago?
8 years. 8 years,
Yeah, it's a
yes.
long
8
time
years.
ago. Discord continues to grow faster than we expected, and so does our user-generated content. With more users come more chat messages. By the way, so they have millions. 8 years later, they have trillions. Insane. In July, we announced 40 million messages a day. Damn. So 40 millions, it's
A day
one
per
day.
month.
Is right? Right?
Let's see.
Divide
Yes.
divide by 4 hours.
It's
Around 1 million by hour. 60 minutes, 27. No. Yeah,
24.
that's by hour.
Yes, I think it's right. Divide by 6.
Yeah, so it's
Yes.
27,000 by
Messages.
minutes.
Yes. Yes.
By second. Not too much, right?
Yes. I think it's pretty. I don't remember the word.
Low.
Yes, not too low, but medium. I don't know if
Yeah,
medium is.
400 it's okay.
Yes,
8 years ago,
average.
right?
I think it's pretty average.
Yeah, average.
Yes.
Yeah. Now today it's billions. So yeah, we're gonna figure out. So we announced 40 million messages a day in December. We announced, and then in December, like 6 months
July.
later,
Mm.
they more than double, 100
Yes.
millions. And as of this blog post, we are well past 120 millions. We decided early on the store, and decided early on to store all chat history forever, so users can come back in any time and have their data available in any device. So it's a lot of data that it's ever increasing in velocity, size, and must remain available. How we do that? Cassandra.
Mm.
So what we are doing, so the original version of Discord was built in just under 2 months in early 2015. 2 months? They
Yes.
use they use they use React
I
for
don't
the
know.
front. So Discord
I
uses
didn't hear
React.
about this code history yet. Actually, I didn't see any company story yet. Not Apple, Microsoft, anyone.
React Flux is
No.
moving to Discord. Their
No.
app is, yeah, they use React and Electron. Yeah, I think they use React in the website too. Okay, 2 months, it's very nice, right? So they have 10 years only. It's very recent. Okay. Arguably, one of the best database for entering quickly is MongoDB. Everything on Discord was stored in a single MongoDB replica set, and this was intentional. So replica set, it's multiple database, right? But we also planned everything for easy migration for new database. We knew we are not going to use MongoDB sharding because it's complicated to use and not knowing for stability. So sharding,
What
it's
does that mean?
another thing about system design. So I'm gonna be open this ColleDraw.
Sharding.
Yeah. So something about system design is sharding. It's the
Mm.
way to create um, scalable products. Oh my goodness. What's happening? My subscription expire. Oh boy.
Renew management
Oh
use
boy. I need to pay back. Can I
I
use
think
for free
renew
just
use free open source editor.
yeah,
Yes.
but I think I lost my stuff.
No. I guess.
I hope so. No.
I think you can
Okay.
renew the subscription gets again.
Get back right.
Yes.
Okay, dark modes. And here we can remove dark mode. Okay, let me draw here. So we have sharding. It's when you have a database
Mm.
and you divide the database across other databases. So you
Mm.
have like MongoDB. Oh, so small. Okay, I can draw differently. I think they call vertical scaling or horizontal scaling. You can check in the GPT for us, Isaque.
Let's see.
But I think sharding,
I never know
like you
the
can ask to them explain, but I think it's vertical. No, it's I think a horizontal scaling.
horizontal scaling.
Yeah, it's
Is
horizontal because
the
you
small
take a table, like you have a table,
Yes, horizontal scaling because you add more machines, each storing part of the data. Mm.
Yeah, so we have a table. Let's call, oh my goodness, user tables. Here, 1 to 20. 1 to 20 rows. And then you take another database and store 21 to 40. You gotcha?
Yes, but why is that good? Why are you? I will do that. Do that.
Yeah, the trade-offs, right? So
Yes.
4160. So because we have one database here for each one,
Hmm.
I can make only 20 users access that one. So
Mm.
I'm splitting the access, right? So also the read and the, for because the database you need
Mm-hmm.
two things, right? Read and
And
write
yes.
access.
Ah.
So you need to scale up that. So if you have one database cross everything,
Mm-hmm.
uh, you need to you're gonna write all the same. Here you like can split and make only a few people write and read that one.
Mm-hmm.
I'm not sure, but I think you can also share them by geolocation. So sharing by
Geolocation.
geolocation allow you divide the
I know.
tables by
Yes.
based on like it's America, it's Asia.
Mm-hmm.
Um, you can check on the GPT for us too, if that's possible. Sharing by location, but I think so.
Share.
Sharing.
Yes, that's a common strategy. Share can be done based on location, so users' data from a certain region go to the same shard. For example, shard one North America,
Mhm.
shard two Europa, shard three Asia, and this help with performance, scalability, and compliances. Queries are served closer to the user, and scalability load is split by region. Compliance is some regions require data residence. But it also brings challenges. Uneven load if one region is much larger, and cross region queries are harder.
Uh-huh.
Mm, Uneven, what does that mean? Uneven.
Yeah, so that's possible. So sharding, I don't
Desigual.
remember the translation for shard, the word. I remember playing Zelda and they have a shared word there, but
Translate.
I don't know the meaning. Oh
Let me
yeah,
see.
sharding it's you
Fragment.
can you can fragment. Also you
Shard
can fragment in
fragmentation.
columns too. Do you know the database called Jesus? What's the name? Damn, it's the biggest database column. Uh, famous column database is the most more used column database around. Damn, I can't remember. Column database. It started with the C letter. I remember. Uh, yeah,
Sigma.
big Google BigQuery. It's column database, but is the other.
MariaDB, Oracle,
MariaDB, SQL also do that. Vertica, I don't know.
Snowflake, competing.
Snowflake, yeah, Snowflake I heard before, but it's not none that. known this. Yeah, when I remember, I I come back. Okay, let's continue here. Let me put that in first one. So we knew we are not going to use MongoDB sharding because it's complicated to use and not knowing for stability. This is actually part of our company culture. Build quickly to prove out a product feature, but always with a path to more robust solution. That's a good one for system design. Like for
But
example, in my project Capital AI, I build using modal.com for deployment, but I'm always looking for how I'm gonna need, if I need to scale, how I'm gonna scale that. Where I need to migrate, how I'm gonna change the system, how much I need to change the code to be able to grow, for example. And so I build in modal.com the project in a way to be able to migrate. It's not connected to easily show. Oh, okay, was more fast. So here, each OpenAI transcribe segments can like speed up one node for each 1 minute of video. So one user with 60 minutes video gonna spin up 60 CPUs nodes, and that made I transcript fast, but also for multiple users. Yeah, and my limit here is 100. So if I need more, I need to pay more. Okay, that's using modal. It's not like the final. If that's gonna have like 1,000 or 2,000, 5,000 users, I should be using something else like Amazon EC2 and something else. Okay, so where we are here, yeah. The messages were stored in the MongoDB collection with a single compound index on channel ID and create at. So I don't know, I don't remember what single compound index is. I think it's when we have two columns that become one index, right? Channel
yes,
ID and create at. Why? Why create at?
create ads. That's a good one. Channel ID and create ads.
Okay, channel ID I understand, but create at, it's not clear.
Around we reach and at this first time we start to see expected issues appearing. The data in the index could no longer fit in run and latencies start to become unpredictable. It was time to migrate to a database more suited to the task. Yeah, they didn't answer about create at. The message were storing MongoDB collection with a single compound index on. I think single compound index it's like no, I can't think of anything.
Yeah, I know in the database when you like create two columns and then you like say, I want to do two columns B1 to be
Yeah.
indexed. And then because they are indexed, they can be searched more fast. Okay, around November 2015, we reached 100 million stored messages. And and that time, we start to see the expected issues appearing. The data and the index could no longer fit in the run. And latencies start to become unpredictable. It was time to migrate to a database more suitable to the task.
Yes, about that is good to see they always trying to see the future, right? When
Yeah,
you trying to make a decision right now, but you can see like you saying in your project in the
Cap2.
Capital AI in what is the name of the website?
Modal? Modal?
Yes, in modal. So you always trying to solve the problem right now, but try to see in the future. So that's a good one to see.
Yeah.
And
So for example, if I have like I had the draws from Capitu, all these system designs, but because I need to pay again, I lost. But basically, I draw first with using Amazon EC2, and that was so painful to maintain. I did the fast hold route that using Modal was much more simpler and also free. So I have like $30 monthly to use, and the trade off was I'm gonna use Modal because it's more easy, it's free, and I need to change my code to adapt to Modal because it's not like normal code. I'm using Python here. I need to change a little bit. I need to understand how Modal used, different from EC2. Like I cannot use normal Docker for Modal. They're gonna create Docker. I could use the Docker, but I try. You can see in the uh, old
live.
lives I did, it was like broken. But then I could develop fast. In the EC2, I can scale. I can grow forever, basically, and I'm gonna pay much less. But then I need to like a DevOps guy, like expert DevOps guys. So that's gonna increase my cost too. So that's the trade-offs, right? So I need to build that, and when I see that starting have a problem, limitations, then I need to do the migration plan. And also in the modal, they have like a structure for saving stuff. And for AC2, I need to like decide between a lot of different place to store, like Amazon S3 or some drive, like Google Drive or any other kind of place to save files, for example. So it's much more complex to decide. So in the beginning, I don't need. So I take the easy way, right? So choosing the right database. Before choosing a new database, we had to understand or read and write patterns and why we were having problems with our current solution. So let me grow up here. Yeah.
Yes,
How
that's
I
good.
close that stuff?
I think you can't. That's
Really?
crazy.
Really? I cannot?
No.
Thank you.
Yes.
So it's it quickly become clear that our reads are extremely random, and our read-write ratio was about 50-50. Random, but it's 50-50. Okay,
It's
makes
complicated.
sense. So they read and write in the same ratio, right? Because normally in database you need to
Mhm.
define, for example, if you have a Tinder app, people are reading more or writing more in the database.
I think
So
reading
if
more.
they're reading more, right? Because they are swiping, then they write.
Yes,
So the ratio can be like like 70% read and 30% write. And based on that, you need to define the database,
mm,
you know, the
cool.
design and the structure.
Mm-hmm.
So voice chat heavy Discord servers send almost no messages. So voice chat heavy Discord servers send almost no messages. Okay. And this means they send a message or two every few days. In a year, this kind of server is unlikely to reach 1,000 messages. They said about voice chat. The voice chat, it's that one here on Discord. You could go in the our Discord.
Link
And
below, guys.
yeah, by the way,
Not
uh,
server.
it's mostly in Portuguese, right? I need to change that too.
Yes.
Create a English channel. I'm gonna do that right now. Why not?
Mm,
General shots English. Done. And so here in the voice channels, we have like voice channel, we have a chat. That chat they are saying they don't have too much messages here because people in the voice chat want to chat, not to type, right? Like
mhm.
to, to talk, not to type. Um, right. So in 1 year, the server is unlikely to reach 1,000 messages. The problem is that even though it's a small amount of messages, it makes it harder to serve this data to the users. Just returning 50 messages to the user can result in many random six on disk, causing disk cache evictions.
These cache
So
evictions.
yeah,
What does
so
that mean?
yeah, you want to search,
Yes,
but
eviction.
evictions
Space
basic.
eviction. Is the process of removing items from the disk cache when space is needed. Since the cache has a limited storage, the system must decide which cache data to evict to make room for new entries. I see.
Yeah, here you can see that I think in the browser. I'm gonna test in another browser. Almost sure if they have
I know.
refresh here, you're gonna see stuff taken from the cache here,
Mm-hmm.
this cache, right?
Mm-hmm.
So eviction is when you change the link, you try access with the like that, right? With the different, you change something here, and then they're gonna evict the cache. So that's the word, right? You're gonna evict the cache to take
Mm-hmm.
the fresh information.
I see.
Yeah.
So in
Here,
ChatGPT we have here LRU, least recently user, LFU, least
yeah,
frequently user, FIFO, first in, first out, and random replacement.
yeah, you have a different modes. So like Redis database, it's mostly used for cache too. So you need to
Mm,
define the algorithm. They have like the caching system have algorithm, caching algorithm. I wrote wrong probably. And one algorithm it's LRU. Yeah, they call policies, I think.
cache replacement policies. Oh,
Hmm. Yeah, you liked it, right? Formulas. Yeah,
yes.
so you have miss ratio and hit ratio. So hit is when people like in the browser. Let me see the browser here. Oh shit, let's refresh again. Here. So memory cache, you see memory cache. So
Mm-hmm.
memory cache is taking the information from the my memory computer, and this cache because it was saved in the disk, right? So if you check the link, let me open here. No, here. You see they say 200 OK from this cache. So they hit the URL, check
Okay.
first the cache, and if they found, we call that they got a hit. If they don't find, we say that you're gonna they missed.
Okay.
So that's the terms. So miss and hit. So they have
Radio.
the latencies. You have something like the algorithm LRU. I don't remember what exactly
Last
that last something, right?
replacement. Yes. Least
List.
recently
Yeah,
used. Least recently used.
yeah. List recently used exactly. So they have others too, but that's the more used. Yeah, you have random. I
Non
think it's random.
frequent.
Yeah, and not frequently used. I never use that one. Aging also it's cool because aging is basically you define if I'm not mistaken you have defined the date expiration basically.
Mm-hmm.
I think that it's aging. It's not crazy. Let me see. Aging is descendants of an initial algorithm with a modification to make it aware of the time spent use. So it's basically that one, and you're gonna see in HTTP. Damn, I think it's cache protocol. Yeah, in
Cache.
HTTP cache control. Yeah, that one I was trying to remember. Cache control. So if the server can control the cache for the browser. You're building the server can say to the browser, hey, make that be in cache until X time, for example. Here, you
Mm.
can say, do not do cache.
Mm-hmm.
And when the browser hits the URL for the first time, they're gonna receive that in the headers, and they're gonna act. I think we can also see that here. Cache control. Yeah. So here, cache control, we have public and max age. So that's the aging. I think that's seconds. I think that's seconds. Max age. So that stuff looks not important, but
IBM, the third one.
yeah, I like to use the Mozilla.
Mm.
Mozilla, it's the best one for,
For this kind of.
yeah. Yeah, they have right here, seconds. So max
Okay.
age, seconds. So max stale, seconds. So stale, I don't remember. I think it's stale, it's how much time you need to have the cache. Minimum fresh, that's also cool. I never used to, but I think it's how many seconds you need that the content is fresh.
Mm-hmm.
No store, no transform, only if cached. So yeah, we have a lot of others here: public, private, but the most used it's public and max age. It's the most used, or not no cache. I think I use that one too. Stay while revalidate. I don't remember why, but I remember I used so many times ago. So let me translate that to English because we are English guys today. Oh, the documentation changed. The Portuguese
Yeah.
documentation is better.
MDM, Mozilla Developer,
Damn.
8HP,
Yeah, the aging here, directives. So
Max
that's
80.
seconds. Yeah, age control. Yeah, the English version is so bad compared to Portuguese. The Portuguese one is much more.
Cache
Look, that
control.
much more organized.
Yes, and straight to the point.
Yeah. So stale is indicate that the client want to answer that uh, that need to be fresh. No. I don't stale here. Indicate that client can accept an answer that exceeds your expiration time. Optionally, you can so basically the client can accept an answer that exceed that seconds in time. Optionally, you can inform a value in seconds, indicating the time in the answer not to be expired. Yeah, I think I used that once. Stay with error. Expect X the answer. I don't know how to spell that one.
Caducidade.
I don't know.
I don't know what is that mean in Portuguese.
Okay,
Caduc-
let's we lost the track here.
Expiration. What? Expiration? Expiration. Yes.
Caduc. Oh, makes sense.
Expiration.
Caducidade, because it's caduco. You know,
Ah, I see.
caduco, caduco.
But we never see
Never,
anyone in my life using this word.
never.
Caduco, I know it's caduco. It's like a
Yeah,
velha caduca.
ultrapassado, fora de
Yeah,
moda.
but like this way, I never
Cadu,
see someone using like that.
caducidade.
Caducidade is crazy.
Caducidade. Oh, it's law. Yeah, I figured out that's law.
I see.
Law stuff. Okay, so yeah, so cache. It's nice we are taking small parts of the article because I'm refreshing a lot of stuff that I forgot, like a lot of stuff. Because basically, 4 years in blockchain, you basically don't use nothing about that.
Yes.
Okay, so we are in this cache evict. So just returning 50 messages to the user can result in many random 6 on disk, causing disk cache evictions. Private text chat heavy Discord service send a decent numbers of messages, easily reaching between 100,000 to 1 million messages a year. The data they are requesting is usually very recent only. The problem is, since these servers usually have under 100 members, the rate at which this data is requested is low and unlikely to be in this cache. I see. It's like the cache is not too much useful, right? On that date in 70, I think the thing changes for trillion stuff. Large public Discord servers send a lot of messages. They have thousands of members sending thousands of messages a day and easily rack up millions of messages a year. They almost always are requesting messages sent in the last hour, and they are requesting them often. So here we need a cache. Because of that, data is usually in this cache. Yeah. So you see, to system design some project, you need to understand all the cases, right? You need to like figure out that a public server gonna act in such a way different for private servers. It made a lot of sense. You cannot build in the same way. We knew that in the coming year we would add even more ways to users to issue random reads. For example, the ability to view your mentions for the last 30 days and then jump to that point in the history. Here, for example, you can hear in the chat. You can go here in the search and mention Felipe.
Felipe Novaes.
And then I'm gonna search and do a lot of reads, and I need to jump from some place. So that he's talking about. So that feature in the past it did not exist, but they want to add. So because they want to add that, they need to take that in consideration to decide what's the database to use.
I see. That's cool.
So yeah. So another was VN plus jumping to pinned messages. So pinned messages is like when you pin a message here, and I can go like to the message. So when I click here, I need to have that one in cache probably. And I want to click, I need to go to the place when the messages leave. With the messages around, right? You have messages around in the top, messages around in the back. So they need to take that or in cache memory or in disk. And the full text search and all of this spell more random reads. I don't know what they say, what they mean by random reads, because I think it's inconsistent, right? They don't have a pattern for people checking the missions, or I don't know. I don't understand why they mean random.
I didn't understand too. All of
Yeah,
this is for more random rates. Random rates. Random rates.
they said in the beginning about the random here. Where here?
Or reason why we have problems, random, or reads were extremely random.
Yeah, I think in random they mean that they don't see a pattern. They don't see a
Mm-hmm.
pattern, like they don't see a pattern like, oh, we have 100 people, that 100 people has 3x reads based on the, no, they see the same number of servers doing different reads. I think that's the random reads they mean.
Okay, I see.
Because if they see a pattern, they can optimize for that, right?
Mm-hmm.
So next, so here, so to define a right database, they need to check all that stuff, understand that sometimes before you build a project, right? You know
Mm-hmm.
you're gonna create a private chat. You're gonna create a public chat. So that from information you already have. Others they discover based on testing. And so next we define our requirements. So they need linear scalability. We do not want to reconsider the solution later or manually reshare the data. Okay. So linear scalability, they are saying if you need to scale more, I want to do click two, three buttons and they're gonna scale. Instead to draw a new database, import and change the data manually, etc.
Mm-hmm.
Automatic failover. We love sleeping at night and build Discord to self-heal as much as possible. Yeah, if the server fail, they're gonna recover automatically. Instead, in the midnight, 3 a.m., you need to wake up to restart the
Uh,
stuff.
low maintenance.
Low maintenance,
Maintenance.
it should just work once we set it up. We should only have to add more nodes as data grows. By the way, if you want to read the others, feel free to read.
Proven to work. We love trying out new technology, but not too new. Proven. What does that mean? Proven to work.
Yeah, proven to work. It's like foi provado que funciona.
Ah, okay. I see. Stable, right?
Yeah.
Predictable performance. We have alerts go off when your or API response time 95 percentile goes above 80 milliseconds. We also do not want to have to cache messaging release or memcache it.
Oh, that's nice. So they have a performance that's predictable. I think that one is because they need to pay for stuff. So they want to like say to investor, we need to more money to grow. Like we need to 2, 10, 50 millions to grow in dollars. And I only can say that much in money because I have a predictability and in the performance
Mm-hmm.
and in the use, right?
Mm-hmm.
And we have alerts to go off when our API response time it's 95%
Percentile.
goes about 80 seconds. So if the API response for the users go more lower, slow than 80 milliseconds, that's insane. Milliseconds, right? It's basically instantaneous.
Yes.
They have alerts, and also they do not want to have a cache message in Redis. So that's cool one. They don't want to have like one database plus a cache in another database because it's against the low maintenance, right?
Mm-hmm.
If you have
Yes.
multiple systems, you need to have more maintenance. You're gonna have more automatic failover. It's hard to linear scalability, so they don't want that.
It's all together.
Yeah. So if you want to
Not
continue,
not a blob store. Writing thousands of messages per second would not work great if we had to constantly serialize blobs and append to them.
You know what blob is?
I know a little bit. It's
Yeah, I don't know what it's the meaning for blob exactly.
but it's a lot of messages together in one
I like see
one
how it's a raw data. Yeah, the binary. So binary data. So it's like a binary large object.
large object.
So yeah, for me it's like always was like a raw data. Because a string, you can like if you see a string or text in the database, it's ASC or UTF-8 codes, right? So you need to like take the string and interpret the string and stuff. And the blob is pure binary. So if you want to save the letter A in ASCII code is 65, or in hexa 41. And if you take 65 per binary, you remember how to do that?
No, it's a long time ago.
I think it's divided by 2, right?
In binary.
Okay, let's learn how to do conversion to bytes. So 65 divided by 2, and then it's already broke, right? Because it's I already broke my I don't remember. I remember need to do MDC, you know? You need to divide by 2, divided by 2, divided by 2, divided by 2, divided by 2. Then we have 1, 2, 3. 1, 2, 3. But that's wrong because it need to be not fractional.
Integer.
Yeah. So what we're gonna do, it's like go binary and be happy. Here.
Yes, I see. Yes,
right? That's the binary?
100,001.
No. Let me wait.
Yes,
Decimal 65 in binary. Right, it's correct, right? Because that's 64 plus 1. But I want to remember now how to do that manually.
For what?
I don't know. Why? I don't know. It's 64 divided by 2. I cannot do by 2. Though I need to do by 3. So that 1, 2, 3, 4, 5, 6, 7. Can do it by 7?
65?
Wait.
Do by 5.
1, 2, 3, 4, 5, 6, 7. So 2 power 7, how much is it?
I think it's 100.
So a 2 power 6, yeah, so it's 6. So let me see if I can divide it by 6. No, I don't remember how to do that.
5, you can do by 5.
By 5?
Yes, because ends with 5.
But then?
I don't know. You can do by 5 and...
Third, no, because it's prime, right? Prime number.
Yes. Only by 30 and 1.
Okay, I need to remember that because otherwise I cannot sleep. GPT maybe? Cloud?
For this, DeepSeek.
DeepSeek.
For math, DeepSeek is better. Mathematics or Grok. Grok is very good for this.
Grok for X? For X?
Yes.
62 binary. How to do manually? Man, I almost sure the result should be 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 1. But I don't remember how to take 65. By logic, you need to go 65 plus less 1, and then 64. 64, right? Divided by 2. 2. Yeah, but I'm cheating, right? because if that's a big number, met to 1. Allah, repeat the division by 2. Oh, the reminder. Yes.
Reminder.
Yeah, the reminder. So the reminder,
The
so
rest.
it's 65 module 2. You know the module? You know.
Yes.
So for people who don't know, module, it's like divide and take the rest, the reminder.
The
I
reminder.
cannot do that. Why? Really? Can I use mode? Yeah, this 1. Then
32.
yeah, then I keep it doing, right? I keep it doing. Yeah, because that first reminder, uh, it's the
It's
first.
because.
It's the first is 10001.
Mm-hmm.
Yeah, basically you just take reminders, right? Like 00000, and then
So it's
again.
pretty easy to do that.
Why 1 divided by 2?
2 by 2 and 0. 1 divided by 2.
Ah, yeah, right. Because 1, 1, 2, 3, 4, 5, 6, 7. Yeah. So 0, 1, 2, 3. Because that's the no, that's not 0. Wait. Here. Yeah, that's 1. 1. Ah, it's 0. You see the 0 here? 0, 1, 2,
Yes.
3. So that's 6. That's 7. Then that. Okay, let's take that number. So mod 2, so 0. And then I need to take that divided by 2. By
Mod.
2. Yeah, so it's mod again. So that's probably 1. I can ignore it, put 1, and then divide by 2. By 2. By 2. By 2.
32,
By 2.
17,
Then you're gonna 1 again.
1 again.
We have already 3 ones,
Yes.
and then we have no anymore. So if you go back, you're gonna have three ones in that number. 1, 2, 3.
Mm-hmm.
Nice. We learned something
Real
useless.
thing.
Okay, they have that one. Find which powers of 2 add up to 65. Yeah, it's the same, right? And the verification. Nice. So blob, it's binary. So basically, you're gonna save in the database that one. Binary. So that's letter, it's A. So why they don't want to save blob? Because you need to take blob, like that's JSON something. You need to take that, transform to ASCII or UTF-8, and then you need to do some parsing. That's too slow, right? So that's why not a blob store. Yeah.
Thousand of messaging. Initialize broad and append to them.
Yeah.
Open source, we believe in controlling your own destiny and the one to depend on a third party company. Discord is open source?
No, but they want a database that to be open source
What is the
because they don't
name?
want third parties put fingers. So that's why they choose Cassandra. So probably they
Okay, I see. I understand.
yeah,
Yeah.
probably they could go with another database. For example, maybe Postgres. No, not
SQL.
Postgres. I don't know how's another new SQL alternatives that's paid. Maybe Amazon, maybe IBM. Maybe IBM has.
See on ChatGPT.
Vamos perguntar pro. Let's ask to. What's
Cloud.
alternative NoSQL paid for Cassandra? Yeah,
Download
Amazon.
Cloud. There's a phone.
Ziri, Cosmos, Google, yeah, Big Table. So I think
No.
they like that. Maybe the Big Table is the good one, but they don't want to private stuff. They have
See.
also ah
Neo4j Aura.
I'm gonna do a spoiler alert. The other article follow they gonna change by ScyllaDB.
Mm.
A C++ rewrite of Cassandra, claiming to be monstrally fast plus scalable.
That's a good marketing here.
Yeah. So yeah, key considerations. So you can see already that it's a good strategy to use like AI to help to decide what tool you're gonna use, right?
Mhm. How much left of this article? I'm tired. Let's see.
Okay,
Let's.
let me see.
Oh, it's
Jesus.
too
Okay,
much.
okay,
We,
I'm
we
gonna
can we can finish this paragraph and
yeah,
we can do, or we can you can do alone. I don't know, or we can finish tomorrow.
yeah.
We
I
can
think
start
I think I can
early.
speed up. I can speed up a little bit, and we can stop here
Yes. Okay.
because it's a half, right? Damn, they had a lot of stuff here. Ah,
Yes.
I just saw that. Just saw that. Big surprise. The
The
future.
future near
Yeah. So I'm
term.
gonna speed up a little bit now.
Yes.
What do you guys in the chat think about that? We can continue tomorrow or and Thursday. Thursdays?
But I
Thursday?
think this part of data modeling is a very good to see more, I don't know,
Yeah.
deeply without the speed it up.
Yeah. So Cassandra was the only database that fulfill all the requirements. We can just add nodes to scale it, and it can also tolerate a lot of node without any impact on application. Large companies such as Netflix and Apple have thousands of Cassandra nodes. Related data is stored contiguously on disk, providing minimum 6 and easy distribution around the cluster. 6, I want to explain that, but I cannot now because of the time. But it's something cool. It's a cool concept for database writing the disks and easy
Mhm.
distribution around the clusters. It's backed by data stacks, but still open source and community driving. Have you made the choice? We need to prove that it would actually works. So they need to prove. The best way to describe Cassandra to a newcomer is that it is a key V store. Key V store. The two keys comprise to the primary key. The first key, K, I think it's K,
Mhm.
right? Is the
Yes.
partition. It's a partition key and is used to determine which node the data lives on and where it's found on the disk. The partition contains multiple rows within, and a row with the partition is identified by the second key, which is the clustering. Fun fact: I need to create and pass a database, so that's why I have a little bit knowledge about that low level stuff.
Mm.
Yeah, but it was mobile database, so it's not too complex compared to desktop databases or servers.
Mm-hmm.
But it's very cool stuff to learn. Okay, so which the second key, which is the clustering key. So the partition, I'm gonna go back a little bit. The partition contain multiple rows within, and a row within a partition is identified by the second key. Okay, it's like a hierarchical folders you can imagine. The partition can be a folder. There are a lot of rows inside, and each rows can identify by the second key, which is the clustering key. The clustering key acts as both a primary key within the partition and how the rows are sorted. You can think of partition as an order dictionary. These properties combined allow for very powerful data modeling. So you can think of partition as a ordered dictionary. So dictionary, we have a key value,
Yes.
and they have the first key to order the dictionary. Basically 0, 1, 0, 1, 2, 3, 4. And then we have 0, they have it put key and value. We have something like that. I think it's linked the list, right? They link the list in Java. Do something like that. These properties combined allow for very powerful data model. Remember that messages were indexed in MongoDB using channel ID and create at.
Yes.
Channel ID become the partition key since all queries operate on channels. Yeah, all messages are in channels. But created at didn't make a great clustering key because two messages can have the same creation time. Exactly. That's why, in the first time I saw that,
Why created that?
yeah, the first time I saw create a at, I thought, but don't make any sense because they're gonna repeat times.
Yes.
So I think they figure out. Luckily, every ID on Discord it's actually a snowflake chronologically storable snowflake. Okay, I'm gonna hold myself to not click that.
Block Geneve snowflake.
Yeah, I'm gonna open just to see the logo. Please, just to remember the logo. I think it's blue. I don't remember. It's
Nothing.
blue.
Blogtwitter.com
Damn,
2010.
Twitter blog. Maybe it's X now.
2010. I don't think that.
Ooh, X now.
Oh,
Look at that. The
but maybe.
designers. Wait, Snowflake is from Twitter?
Oh, I
Oh,
didn't know that.
so network services for generating unique ID numbers at high scale with some simple guarantee. Ah, nice. Oh, that's nice. You need to
Cool.
generate ID numbers in high scale. Snowflake. Not anymore, right? Because it's archive. Maybe they have now better stuff like that one.
Mm,
Finago,
mm,
maybe. I don't know.
mm.
So we are able to use that instead. The primary key become channel ID and mention ID. Now makes sense.
Message ID.
Where
Much
the
better.
message ID is the snowflake. So you can see here, if you go to the message and copy the message, copy copy link message. If I paste here, you're gonna see the numbers like this.
Mm,
That it's basically a server because they call always channels, but that's the server. That's the thread or the group, the real channel, and that's the
mhm.
message.
So
Before,
Snowflake is an algorithm. Your
yeah,
algorithm to do that.
yeah, exactly.
Oh.
Exactly. This means that when loading a channel, we could tell Cassandra exactly where to run the scan for messages. Here a simplified schema for a message table. This omits about 10 columns. Channel ID, begins, message ID, author ID, content, and primary key is channel ID. Yeah, they call primary key. I don't know why they call index there in the top. It's not the correct, I think, word to that.
Begin.
With the clustering order
Oh,
by
message.
method ID desk. While Cassandra has schemas, not unlike a relational, while Cassandra
Database.
has schemas, not unlike a relation. Oh my goodness,
Unlike a relational database, they are
database
cheap filter and do not impose any temporary performance impact. We get the best of a blob store in the relational database.
store. Yeah,
They
they
are
said
cheap.
blob store, but they are telling about like NoSQL, right? You can
Mhm.
have a
Mm.
relational stuff, but also not relational.
Mhm.
When you start importing existing messages into, I think so, or that's from, yeah, don't make any sense that to be, it's not MongoDB, that one. You can see schema CQL Cassandra.
CQL.
When we started importing existing message into Cassandra, we immediately began to see warnings in the log telling us that partitions were found over 100 megabytes in size. What gives Cassandra advances that it can support 2 gigas partitions? What gives? I think they said, what gives? It's like expression. Cassandra adverts that it can support 2 gigabyte partitions. Apparently, just because it can be done, it not mean it should be done. Yeah, that's another stuff to learn, right? So Claude can say for us that Cassandra is good for our application because they can support 2 gigabytes, but in practice,
100
only 100.
megabytes.
Yeah, apparently, just because it can be done, it's not it should. Larry partition put a lot of GC pressure, garbage collection on
Mm-hmm.
Cassandra. I think it's garbage collection. Pressure on Cassandra during compaction. Yeah. So put a lot of GC pressure on Cassandra during compaction, cluster expansion, and more. Have a large, imagining 2 gigabytes, probably all in memory. I don't know. For each partition? Have a large partition also means that data cannot be distributed around the cluster. It became clear we had somehow bound the size of partition because a single Discord channel can exist for years and perpetually grow in size. So they cannot use a channel, I think
No
they are
idea.
saying. We decide to bucket our message by time. We look at the largest channel on Discord and determine if you store about 10 days of message within a bucket that we could comfortably say under 100 messages.
Mm-hmm.
Buckets has to be derivable from the message ID or the timestamp. So they have a Discord epoch. The bucket size is 100 megabytes. No, it's time. That's time. 10 days. 10 days. So 10 days, hours, minutes, seconds, milliseconds. So you're gonna save 10 days, then create a bucket.
Mm-hmm.
If you don't have a noise snowflake yet, they're gonna create based on time. No, they're gonna create a timestamp. Otherwise, they're gonna shift 22 bytes the snowflake ID, basically cutting, take only the 22. I don't know how the size, but take one part that and divide timestamp by the bucket size. Okay, yeah, because you want to date 10 days. 10 days. So the snowflake ID shift 22 because the algorithm has timestamp inside the snowflake ID, I guess. Okay, then you call make buckets that call range make bucket start ID and ID. Okay, Cassandra partition key can be compound. So our new primary key become channel ID
And
in
bucket.
bucket and then
Mm.
messages. So it's channel ID com bucket, and then that's a new private key for message ID. That's crazy.
Mm.
That's crazy. I see. Channel ID with the bucket because they have a channel ID for each 10 days. And
Mm-hmm.
then you have the messages.
That's
That
crazy.
that's something. It's insane. Just to see that,
Yeah.
it's insane. To query for a recent messages in the channel, we generate a bucket range from current time to channel ID. It's also Snowflake and it has to be older than the first messages. We then sequentially query partitions until enough messages are collected. The downside of this method is that rarely active Discord will have to query multiple buckets to collect enough messages over time. In practice, this has proven to be fine because for active Discords, enough messages are usually found in the first partition, and they are the majority. Yeah, they treat it such a way that, like if you take here Cartesius, you see this the refreshing to load, they
Mm-hmm.
go always to load the first bucket. So the first bucket is going to be always 10 days. I think if you keep scrolling down, they're going to start in refreshing. See? Refreshing more than 10
Yes.
days. And the refreshing. in the same channel.
Mm,
Okay, so the downside. Okay, importing message into Cassandra and without a hitch, and we are ready to try in the production. So the importing was easy, and we can finish here. Then they have dark launch, eventual consistency, performance, and the big surprise, and the future.
long
Yeah, you can
term.
see in the future here, the long term. They said exploring using Scala, Cassandra compatible database written in C++, during normal operation or Cassandra nodes, not using too much. I think then, because that in the next article, they
Trillion.
started have a problems with Cassandra because they run 20 Cassandra nodes storing billions the
Of
messages.
this.
When they started to go to trillions, I think they broke everything.
Shabu.
So it was very nice. We read the first article, so then we can understand that was very easily when we
Yes.
start to read.
And you can learn a lot. We have read only the half of the
Yeah,
first article, and we see a lot of concepts and things.
just for
And
databases.
yes, and how to think in scalable things in the future and so on. Imagining a whole month doing this,
Hmm.
reading these kind of articles and everything.
Yeah, that's why we're gonna do the series about system designs, and that's the beginning. I have other articles, for example, how to Google Docs works. Um, you can understand how, like, I think it's operational transform they call for do the real time docs, like people change the docs in real time, how they synchronize everything in servers. So they're gonna, yeah, OT. And then I'm gonna explain also the alternative called conflict free replicated data. That's beautiful. But that they're gonna keep for the next time. I think gonna be 26.
Yes, Tuesday.
Nice.
Tuesday. Yes,
Or
Tuesday.
tomorrow if you
Yes, tomorrow.
get it.
Tomorrow we can do.
Or tomorrow if you get excited to do to
Yes,
finish
we
with one.
can do tomorrow.
Nice. So thank you for people that watch and people gonna watch later. And thank you, Isaque, for being here, practicing English, learning more about system
That's
design.
it, guys.
It was very
I'm
cool.
here more as a student. Felipe knows so much about that.
Yeah, I
It's
also
me.
learning a lot of stuff to learn forever.
Yes, but I think in 2 months we can know a lot of software architecture.
Yeah, I agree. 2 months if we do two lives per day per week,
Mm-hmm.
it's eight, right? No, more. Yeah, it's eight
Yes,
lives.
it's 8 lives per month, 16 lives, but we
Yeah.
will study offline. I'm reading some books from O'Reilly Edit. How can I say editora? O'Reilly
Nice.
publisher.
Publisher, yeah, publisher.
Yes, O'Reilly publisher. And I want to try to read these books, and we will see how much can I learn. In the next life, I will be better and better and better, and that's the way to learn.
Okay, I have a video very cool to watch. We can watch tomorrow. I also gonna share the link in the Discord. So if you're not in Discord yet, I'm gonna check my history, and they have a awesome. I think it's 30 minutes. They show all the core parts for understanding system design, and the idea is we see all that thing in deep in the life. So and then you in the chat you can make questions about and show and share links to we learn together.
Yes.
So thank you again, and see you guys.
Bye, guys. Subscribe, give the like, ativa o
Yeah,
sininho. I don't know how to say that in English, but
I think it's
push
activate
the sign.
notifications.
Yes, keep push notifications. How can I say sign in English?
Signing, signing,
Signing.
signing.
Bells.
Pablo Pereira. Good night,
Push.
guys. Thanks. Nice. Thank you, Pablo. Thank
Yes,
you.
Pablo. Thank you, man.
See you tomorrow.
Tomorrow will be on again. That's it. Bye, Felipe.
How I stopped that? Yeah, remember there.
Yes.